Hi, and welcome to this episode of my chemistry podcasts. I'm going to be looking at a very simple concept today, and that is representing chemical reactions via ionic equations. And while it is simple, many students seem to have some difficulties with it. Before we can look at how to use an ionic equation, we first need to understand what an equation is. Now, most of us first experienced equations in primary school when we looked at mathematical equations. I've got a simple example here. 2 plus 3 plus 6, that will add up to give us 11. 4 plus 1 plus 6 will also add up to give us 11. So they are equivalent sets of numbers, and we can join them with an equal sign. When we have the equal sign joining the left-hand side and the right-hand side, we have an equation. Notice that both the words equal and equation start with the same four letters. But if we look closer at this equation, we'll see that there is the number 6 on both the left and the right hand sides. Now if we remove 6 from each side of the equation, we still have a valid equation. 2 plus 3 equals 5, and 4 plus 1 equals 5. So whatever you do to the left hand side of the equation, if you do the same thing to the right hand side of the equation, you still have a valid equation. Now let's represent these numbers as circles. For example, if we had 2 blue circles and 3 red circles on the left hand side, we can see that on the right hand side we'd still have 2 blue circles and 3 green circles. Because they're equivalent left and right hand sides, we can join them with an equal sign. Now if those circles represented atoms in a chemical equation, we don't actually use an equal sign in chemistry, we use an arrow. And the arrow represents the direction that the reaction is going. So let's have a look at a typical chemical reaction and see how we can represent that with an ionic equation. The reaction we're going to look at is involving the chemical potassium iodide solution. Now potassium iodide solution, if we look at the test tube containing the yellow liquid, we would be able to see that there are potassium ions present in the solution. There are iodide ions present in the solution. Obviously there'll be water molecules present. And if we looked at other things surrounding that liquid, we'll see that there's Pyrex in the test tube and air above it. Now we're going to mix that with another solution. We're going to use some lead nitrate. And again, if we look at the contents of this colourless solution, we'll see that there are lead ions, there are nitrate ions. Again, there's water molecules and Pyrex and air. Now, I've titled both these slides reactants because they're the things that we're starting with. And if we look at what we have in total, we have potassium ions, iodide ions, water molecules, Pyrex and air in the potassium iodide. We have lead ions, nitrate ions, water molecules, Pyrex and air in the lead nitrate solution. Looking closely at that, we see that the water, Pyrex and air is present in both, so really it only needs to be represented once. So now we've got a list of chemicals that we begin with. What I'm going to do now is just show a short video of when I mix the two liquids together so you can see that the reaction that does take place. You can see that a yellow solid, an insoluble yellow solid, has been formed. If you leave it settle for a while, you see that the solid settles down to the bottom and a clear liquid forms on the top. What you'll have present now is lead iodide, which is the solid, which is the insoluble precipitate which is formed. There is still potassium ions and nitrate ions, and there's still the water molecules and obviously the test tube made of Pyrex and the air above it. So if we look at what we started with and what we finished with, I've listed on the left hand side all the things we began with, and on the right hand side all the things that we ended up with. We see that there's a whole lot of things which are unchanged, which haven't taken any part in the reaction, which we could remove because they haven't done anything. So let's remove those list of chemicals. If we remove them, we'll see that now we have only the things which took part in the reaction, and that are the lead ions and the iodide ions, and the final product, which is the lead iodide. All we've got left to do now is to write a balanced equation. And we do that by placing a 2 in front of the iodide. And now we'll see that the only reaction that took place is the positive 2 plus lead ions and 2 iodide ions for every 1 lead ion have combined to form the ionic crystal lead iodide. We haven't involved any of the other ions which were present, the potassium ion, the nitrate ion, or the water molecules, because they are known as spectator ions. They haven't played any part in the reaction and therefore should not be put into the equation. The equation should only be representing what is actually reacting.